chat in the YouTube where this live posted, or you can ask questions in the Slack channel. I'll be monitoring both places, so whichever one is hosted, or you can ask questions in the Slack channel. I'll be monitoring both places, so whichever one is more convenient for you guys. If you have a YouTube account already, you can just underneath the video, if you're watching on YouTube, you can just type into the chat there, or just chat in the Slack channel under the question in the question channel. So today's lesson, I'm going to just kind of briefly talk about what's going to be basically covered inside of this week one, the very first week about the blockchain, what material we're going to cover. I'm just going to have a very brief introduction and have you guys kind of go through each of these lessons here to learn more in depth about some of the important concepts and theories that underline the blockchain technology. So yeah, like I said, this week one is more about learning about the important concepts and theories instead of doing a lot of coding. We'll do definitely a lot more coding in week 2, 3, and 4. But for the first week, we'll do a little bit of coding for the project, and we'll have you basically kind of go through the series. So for example, in the first lesson after the live class is the peer-to-peer network. You can watch the video. And then we have some key takeaways in terms of notes and some additional reading materials that you can check out. And also, each lesson has a little quiz at the bottom that you can do to check your understanding to make sure you actually really understood the important concepts in the lesson. So make sure you check out the quiz. Don't worry, we're not marking you for the quizzes. There's more for a self-assessment to make sure that you actually understood it. So there's no marking given to the quizzes. But for the projects each week, we'll be grading you on the projects. So that's the other thing I kind of want to talk about is some of the logistics for the course. So if you guys have any questions at all, make sure to type it into the Slack channel or on the YouTube channel. Yes, class has already started. Thank you, Patrick. So it's really great so far. Hope you guys are had the first week 0, to go through the JavaScript primer stuff. I know not all of you guys have a programming background, and some of you are just starting out. So I think it's the reason why we picked JavaScript is because a couple of different reasons. One is the smart contract language that we'll be building, Solidity, has some similarities in terms of syntax to JavaScript. And also, when you build a smart contract, you want to have some kind of sort of front end, maybe like web application that interact with your smart contract. And it's just right now the easiest way to do it is just to do it in JavaScript. There's a lot of libraries, the really well-established libraries are written in JavaScript, but there are libraries in other languages as well. But JavaScript is kind of the de facto standards right now in terms of interacting with your thing. Okay, cool. I'm just gonna try to make my screen a little bit better for you guys. Let me see if I can make this thing a little bit brighter. Yeah, okay, sorry. Okay, so basically, as I was saying, so the JavaScript primer is basically for you guys to kind of, get up to speed with some programming background and knowledge. And I know a lot of you already have submitted your week 0 assessment, which is great. For those of you who haven't submitted yet, I suggest you try to get it done within the next day or two. I don't want you guys to fall too behind in this program because after this first week, the week 2, 3, and 4, we're going to have a lot of coding involved with the projects. And I think my philosophy is that the best way to learn is by doing. So that's why we have a lot of coding and stuff assigned for you guys. When are the assignments due every week? So our tentative deadline right now is for every Monday to have the project due. But I know you guys, a lot of you guys are working full time. If you want to have a longer extension, just message us, let us know. But right now we're setting the default deadline due on Monday. So for example, this is week 1. So week 1, you guys have a project here. You can see there's a little project. Don't worry, the week 1 project is pretty simple. It should be very straightforward to give you guys a chance to kind of catch up from week 0 and week 1. But starting from week 2, we'll have a lot more coding. But yeah, so for example, week 1, the project, I would say it would be due next Monday. So it would be due next Monday at midnight, say for example. So after the live class, you guys can submit your project. But if you need an extension, definitely just shoot us a message and let us know. Yeah, it's definitely week 0, but my environment set up for the most part. Yeah, great. Yeah, just have a chance whenever you have a chance, Travis, to get the week 0 stuff done. That'd be great. Like I said, it's the first week. We'll give you guys some leeway, but going forward more, it'd be good if you guys can get more involved. But yeah, if you need extension, just let us know, which is fine. Okay. We understand it's an online course. You guys have full-time jobs. You may have kids or family to look after, and things happen. I get it. It's definitely tough, but I definitely give you guys a lot of credit for even just signing up for this class, taking out the time, extra time to come and learn this stuff. I really think it'll be beneficial to your career and really beneficial to just learning. So without further ado, I'll just kind of start a little presentation. I'll keep it short. Like I said, it's kind of give you a great. This presentation is kind of give you an intro of some of the key ideas and concepts in blockchain, and each of the lessons in week 1 will dive deeper into these subjects and topics and give you more information. So definitely just check out all the lessons in week 1, watch the videos, read through the notes. The notes are not just a summary of the video, it also contains additional information that we didn't include in the video that we thought would be interesting and supplementary to the video. So check it out. We have a bunch of links and stuff to extra readings if you are interested. Some of the reading materials are quite long, so don't feel bad if you cannot read everything. They're just kind of there for reference for you guys, so that whenever you have the time, you're like, oh, that topic I remember Jacob was mentioning about in this particular lesson. I wanted to learn more, so you can go back and click the link and read more about it, right? So without further ado, kind of just today's agenda for this talk, we'll look at some of the give you some background information and motivation, give you some introduction to some of the key concepts in blockchain, and we'll actually do a smart contract demo, show you guys how to interact with smart contract, create contracts, set up an account, and get you set up with some testnet ether and things of that nature. Will the live class be available on YouTube after class? Yeah, so the live videos are going to be basically made available after the stream. We'll basically, if you go to the website, Accelerate program, right now the live class just kind of shows the time and a YouTube link, but eventually we'll replace the YouTube link with like a better YouTube video player, like similar to the one in each lessons. So we will definitely make all the stuff available to you guys after the live class. The live class is basically an opportunity for you guys to kind of interact with us, ask us questions, and also, if you can't make it, that's totally fine. If you're busy or something, you can watch the replay after, but you might not get that real-time feedback, the real-time interaction afterwards. See if someone on YouTube. Okay, cool. Record provide as a reference for futures. Yeah, all the videos are going to be available for you to access whenever. Computer science, I couldn't fix for me. Okay, yeah, I know. I understand some of you guys were having a lot of trouble with Vagrant and setups and with different laptops and stuff like that. Yeah, don't worry if you have that issue. If you can't make the deadline for the project, just let us know. There's some other alternatives I can get into later. If you don't have a laptop, there's like cloud environments and stuff like that, but some of them cost money, some of them are free, but it just depends on what you want to do. But I can get into some of that stuff later, but let's kind of keep going with today's agenda. So just a little bit about BlockGeeks and who we are. Basically, we provide the online training, engineering talent training through guides, articles, courses, and boot camps and certifications such as this one. And we'll also be coming in person as well at the end of the course. I think right now the date is set for November 30th, the Friday and the Saturday. We'll be coming down to Bahamas, and we'll be kind of finishing up the course with a weekend hackathon / bootcamp type of thing to end the program. And we also do some security audit stuff as well. If you guys ever in the future, graduated and working in a blockchain company and you need some smart contract audits, we also do them as well. So a little bit about me as your instructor, lead instructor for this course. My name is Jack, and basically I graduated from the University of Waterloo. I studied computer engineering, and I've been working in the industry for about 5 years. So first when I graduated, I worked a couple of years at IBM. I was doing some compilers and runtime stuff. And then I worked a couple more years at a startup doing cross-platform mobile development. And now I'm an instructor at BlockGeeks and teaching you guys about blockchain technology. And I kind of got into the blockchain space in around 2014. I heard a lot about it, and I really kind of looked into it, and I thought it was really interesting about how decentralized currencies and all that stuff, especially after the financial crisis in 2008. A lot of people kind of start waking up to the fact that, hey, something kind of weird going on here. So that's a little bit about me. So kind of give you guys some motivation for this course, why you want to become a blockchain developer. Hopefully, give you guys motivation to kind of work hard in this course and get all the project done. Basically, blockchain technology has the ability, to really impact the world in multiple different facets in the way we do finances, trade, and a lot of different areas in our society. And basically, you have a good opportunity to kind of build your own idea, your own business, to disrupt a certain industry. But if you're also looking for a job as well, the blockchain industry is great for having remote jobs due to the decentralized nature. A lot of companies, especially even really big ones like ConsenSys, they have a decentralized working model where a lot of people work remotely, and there's basically a high demand and there's a low supply right now. So definitely is a good time to get in, I would say. And basically, a lot of opportunities here for you guys. So that's a little motivation for you guys to kind of get you motivated to kind of go through this online learning course. I know it's hard, especially if you have a full-time job, but definitely a lot of credits to you guys for taking this on. So kind of just let's start, like, what is a blockchain, right? What is this thing about? What's up with all the hype, right? So you might have seen some picture like this with some blocks and some arrow linking it. Kind of looks like a linked list. If you, as many of you have some computer background, you know what a linked list is, right? Looks like a linked list data structure. And often you probably hear like, oh, it's the thing that makes Bitcoin work, right? Which is true. But more technical definition, I would say some things along these lines is that it's a database that is replicated across a peer-to-peer network that maintains a consistent state through a consensus algorithm, right? So there's a lot of key terms I kind of highlighted here, right? So one is kind of like a data store. It's not exactly like a traditional database, but you can think of it as kind of like a data store. There's definitely databases being involved in it, but it's a place where you store data, right? But this data is stored basically across a peer-to-peer network, right? So our first lesson in week 1 dive into deeper about what peer-to-peer network is. So I'm not going to get into too much detail, but basically the idea is that anyone can connect to anyone else. There's no central authority, right? And this data store is replicated, which basically means that all the different nodes in the network has a copy of this data, right? But because everyone has a different copies, one of the problems you need to do is that, well, how do you make sure that everything is in sync, right? If there's 1,000 copies of the data out there and they all say different things, then it's not very useful, right? So we need to keep all of the copies out there in sync somehow, right? Because otherwise, imagine you have 1,000 different copies. One copy says Bob has 10 Bitcoin. The other one says he has 1. Well, how many Bitcoin does Bob have? We don't really know. And the way that these different nodes keep the data in sync is through something called a consensus algorithm, which is covered in more detail in the week 1 lesson. So I'm not going to get into too much detail. I'll kind of give you a high overview of what the class is about. This week's lessons are about. But kind of stepping back from just the technical definition, as a blockchain, as a system, you can kind of think of it as like a multidisciplinary system that is designed with economic incentive to achieve a set of desired outcome. So what really makes the blockchain kind of special is that the inventor, especially for Bitcoin, for example, when he designed a system, it wasn't just purely a technical decision of using what tech stack or using what technology or what language, what database, but he designed, he thought about how humans behave and human behaviors, and he designed a system to promote certain desired behavior from the users. And a great example is that file sharing. BitTorrent is a decentralized application where people share files with each other, and it's kind of hard to shut down because it runs on a peer-to-peer network. But we all know that after you download a file, you might not be so eager to seed and let other people download the file, right? You might just download the file and then just quit because there's no economic incentive for you to seed the file. But now let's imagine that if you're a torrent system, you download a file, you seed the file, there's actually economic incentive. Imagine if you seed the file for a long time, you actually make money. Well, then you're more likely to seed the file, right? So that's one of the additional thing that's kind of that makes this multidisciplinary is that this additional layer of being designing these human behavior, psychology, and economic incentive into the system, right, from the start. So that's what I kind of call the mechanism design in the bottom column here with the bag of money. That basically involves game theory stuff, economics, and system design, all these things. Right, so kind of going back to this, with this linked list, what is a blockchain? So I'm kind of going into a little bit of detail about kind of the structure, but the lessons in this week's course will dive into greater details. So a block basically contains a list of transactions, okay? So it's basically, block is just a holder for transactions. So transactions are kind of like the fundamental kind of element or the data structure of the blockchain. But what is a transaction? So for those of you, Bitcoin is kind of, very easy to understand, right? So a transaction in Bitcoin would be basically something like Alice transferred 10 Bitcoin to Bob. So Alice would create a transaction that says, I want to transfer 10 of my Bitcoins to Bob. And that will be a transaction. So in Bitcoin, a transaction is kind of like encoding of a transfer of ownership, if you will, right? But in general, because this course is not about Bitcoin, this course is about Ethereum. But it's good to understand, the history of Bitcoin, history of blockchain, which is the very first one being Bitcoin, to understand how things are different in Ethereum, right? So in Ethereum, or in more generally speaking, in any blockchain, a transaction is basically a piece of digital data that's been signed, right? What I mean by sign is that as you learn in this week's lesson, cryptography is that you sign something with what's called a private key. It's basically only the owner of the account. He only has access to his private key, and whenever he needs to do a transaction, he needs to basically approve this transaction by signing it with his private key, right? It's kind of like signing a piece of document in real life, right? You have to give the authorization to do something because you're the owner, for example, right? And then this piece of signed data changes the state of the blockchain after this transaction has been included in a block. So there's some keyword here. So there's a state of the blockchain. So the blockchain, the state, you can think of it as like what is the data being stored in the blockchain, right? So for example, Bitcoin is like, each person has this amount of Bitcoin. That's kind of the state. Now imagine Alice transferred 10 Bitcoin to Bob. Then the state will be updated, right? Now the state will say Alice will have 10 less Bitcoin and Bob has 10 more Bitcoin. So the state has been updated. So a transaction is basically a piece of data that will basically change the state of the blockchain after it has been included in a block. And how a transaction gets included in a block is a process called mining, and also is related to consensus algorithm, which is also covered in this week's lesson. So definitely check out that lesson and watch the videos and read the different description and do the quizzes, and you'll basically have a better understanding of that. So that's kind of a brief overview of the components of the blockchain that you'll learn more about, and basically how secure the blockchain. So one of the unique thing about blockchain is its security. How it achieves the security, it uses kind of three main different mechanisms, okay? So the first one it uses is modern cryptography, okay? In particular, there's two aspects of modern cryptography it uses. One is called digital signature, that is used for proof of ownership, right? Proving that, you actually own this Bitcoin and you can actually transfer it. And cryptographic hashes are used to keep the blockchain immutable. So as you're learning this week, immutability basically means that once a transaction is included in a block, that transaction cannot be altered anymore. You basically cannot go back and erase history, right? You say you transfer 10, but going back and no, I changed it to 5. That's not going to work. And the second way it achieves security is through what's the consensus algorithm or consensus protocol, which maintains consistent state, right? You can imagine that one of the problems with a peer-to-peer network is that you can, especially in a public blockchain, anyone can join the network. You can have malicious actors trying to purposely send false data to other people. It's purposely trying to confuse everyone in the network, right? To basically come to disagreement about what is the truth. And when you can do that, you basically render that whole thing useless. It's kind of like a denial of service, right? Like I mentioned, if you have 1,000 copies of the data source saying different things, then nobody can trust what is the truth. Then it becomes not useful, right? So that's a consensus protocol. And also additional layer that I already mentioned is economic incentive. So you penalize bad actors and reward good actors with actual economic incentive, right? Because everybody loves money, and we live in a world that we need to use money to survive. So, economic incentive works. So I'll just leave it at that, and we dive into these greater topics in this week's lesson when you go and watch them. So I just want to kind of briefly talk about Ethereum and how it's a little bit different, and how basically, and we'll look at some smart contract example for Ethereum. So basically what happened was Bitcoin came out, and a bunch of other projects also came out, and they basically wanted to use the blockchain for other purposes rather than just transferring money. And one of the problems that Vitalik Buterin in 2013 realized is that everyone who wanted to create a new application using blockchain, they have to create their own blockchain. So they basically had to fork the Bitcoin's code or create their code from scratch, which is very difficult to do and error prone and takes a long time. And also, you have to convince the users to use your blockchain, right? Whereas if a user is already using Bitcoin, why can't they just use the same network, but you can have another application built on top of the same blockchain, so you don't have to go and download a different blockchain and download the different tools, create a new wallet, create new addresses, and dealing with all that stuff, right? So that's what Vitalik realized, like, why don't I have a general purpose programming language that's built directly into the blockchain that allow anyone to use that language to build any applications on top of it. So that was the key idea, right? So in the case of Bitcoin, Bitcoin only really just used the blockchain to store the user's account balances. But in Ethereum, it says instead of storing account balances, I just store the entire program on the blockchain. And then once the program is on the blockchain, people can actually execute code, the code within that program by basically sending transactions to it. And the program can maintain some internal state. So that internal state of the program could be is basically whatever the application is for, right? For example, like a ERC20 cryptocurrency, as you'll learn later on in this course, I'm sure some of you are aware, like these ICOs, right? Initial coin offering, they're offering these coins. Basically, they wrote a program, and the program has internal state. So, for example, these state are like, how many the user balances, like how many coins does this person have, right? That's basically what a coin is in Ethereum. It's really easy to do. You just write a simple program, right? Keeping track of balances of coins, right? You're basically replicating what Bitcoin is, essentially. So you just create a new cryptocurrency, essentially. But you can use it to do anything you want, really, right? Because it's general purpose. So then basically in a diagram speaking, basically what Ethereum did is, in the diagram here on the left, when you have to build your blockchain, there's really kind of three components to a blockchain, right? There's the networking layer, the consensus layer, and the application layer. So the networking layer deals with like the peer-to-peer network, how do you discover peers? Once you discover them, what's the communication protocol you communicate, and then how you retrieve data and send data and things of that nature, right? All the routing stuff, all the networking stuff. And then you have the consensus layer, which basically you have to make sure that all the nodes agree on what is the truth, right? So that's the consensus layer, and the application layer is where the all the different data that's particular to your application is stored. So in Ethereum, what basically happened is, instead of replacing application, basically they wrote something called the Ethereum virtual machine, right? Which is basically just a thing that can execute programs, right? If you guys done a lot of Java programming, I'm sure some of you have done, there's the JVM, right? The Java virtual machine. So the Java virtual machine, in Java, basically they made it powerful that you can write a Java program and be able to run it anywhere, right? That was the ethos of Java, is you can run it on mobile, you can run it on embedded devices, you can run it on the web, you can run it on desktop, Windows, Linux, wherever, right? So it took the job away from the developers to make sure that it runs on the particular device. It made the designer of the virtual machine had to make sure it runs everywhere, right? So the virtual machine is basically a program that essentially takes in your program in Java and execute that program, right? And calculate the correct results, whatever, and store a different state. So basically, it's the same thing. It's very similar. All the virtual machines are very similar. A lot of them are basically stack-based languages. So that's a little bit more detail you don't really need to get into right now. But basically, there's like a stack that emulates different operands. You push something onto the stack and pop something off, and you add the results and pop push the results back onto the stack and things of that nature. That's basically how like virtual machines usually work. They're actually pretty quite simple and quite straightforward actually if you look into how they will actually work. But basically, the Ethereum virtual machine understands basically what's called a set of opcodes. And so you have these dApps, and basically you write the programming language and you can run it on top of the virtual machine, right? You write your program and it runs on the EVM. So, basically how these smart contracts work, like I said, smart contract is basically a program that has some state and some methods, and basically you write these smart contracts in a high-level language and compiles them down into EVM bytecode, right? These are lower-level machine-like languages. That's how the EVM operates. So they have like operations like add, subtract, load, store, and things of that nature. If you guys have studied, languages and compilers and stuff like that before. But don't worry, that's just a low level detail. You don't need to worry too much about. But basically, you'll be writing stuff in Solidity. Solidity is the most popular language today for smart contract, but there are other languages such as Viper and other ones as well. So basically, they all compile down to the EVM bytecode, and then they run it on the Ethereum virtual machine. So this is kind of a high-level overview of how smart contracts work. So actually, without further ado, let's just dive into some smart contract demo. So don't worry if you don't understand everything, because next week is when we really dive into smart contracts. But I kind of want to just give you guys a teaser right now to kind of see what it is about. So before I do though, is there any questions so far? If you do, just please type them into the YouTube channel or on the Slack channel. I'll definitely just answer them. So to get started, so what do you need in order to kind of interact with the Ethereum blockchain, right? So one of the first things you need to have a wallet. So basically, a wallet is basically a software that manages your private key and your public key for you. So basically, you need to download something called MetaMask. So if you just go to Google and just Google MetaMask, you'll see basically MetaMask.io is their website, but there's a Google Chrome store. So this is a Chrome plugin, right? It works on Chrome. I believe it also works in Firefox. I'm not exactly sure. Okay, so I use Chrome personally. So I don't think it works in Internet Explorer, but I just say download Chrome if you don't have it. If you have Firefox, it probably might work on Firefox. I'm not too sure. But yeah, so MetaMask basically is a Chrome plugin. You can just go to the Chrome store and then install it. I already have it installed. So this is their website. Kind of, if you curious to check out the product, you can check it out. But I already have it installed. So what it looks like a little fox up top here. So I already have kind of a account here. So it looks like they have a new version actually. Okay, so but anyways, so this is the MetaMask interface. The first time you come in, it's going to ask you kind of for a password to basically make sure it's secure and all that stuff. So typing a password, and then basically you can interact with the Ethereum network. So Ethereum has a main Ethereum network, which is the main Ethereum net, which is the Ether worth real money. But Ethereum also has a bunch of test networks. So the purpose of the test network is for developers to test their applications on, and just to play with the blockchain without actually costing any real money, right? Because Ether costs real money to buy. So basically, I have an account set up. You can just generate an account by clicking the little account icon here. You can just say create account, and this will actually just create a new account for you. So I already have an account created, and you can edit the name of the account and stuff like that, right? And then the address is kind of basically down here. You can actually, just click this button and just say copy address to clipboard, and then you can basically have your address there. So that's an Ethereum address. So an address is basically a kind of like a unique identifier that identifies your account. So as a user, you can have some Ether, right? You can have some cryptocurrency Ether, and basically when you create an account, there's basically an address. So you can send this address to other people who you want to receive money from. So this address is basically kind of like, think of it as like your bank account, your public bank account, right? So that's kind of, so the Ethereum address is related to the public key, but it's not the public key, but it's derived from the public key. But anyways, you can think of it as like the public key. So the Ethereum address is kind of like your public key that you can send to other people, and other people can send money to you. It's kind of like your bank account, right? But your private key, which is your password to your bank account, that you keep private, right? You don't give your bank account password to other people. You can give them your account number so they can send you money, but you don't give them your password. So that's it's kind of like private key. So you can send this to other people, and they can send you Ether, right? So the way you will get some testnet ether, actually you can just literally click this buy button here, right? So basically what you should do is change it to Rinkeby testnet, not the main Ethereum net, because we'll be using the testnet to basically test things out. So it's free. So there's a Rinkeby test faucet. So you can click that, and that will actually take you to a website, and basically they will have instructions here. Okay, so you have to go to the left side here. It says crypto faucet. On the very left hand side bar, there's a crypto faucet tab here. You click this. Okay, so yeah, I just loaded and I clicked it again. Let me just be patient and let it load. Okay, so you load it. So there's some instruction here on how you have to, in order to get it. So here you can paste in your Ethereum address like I did earlier, right? So I can paste in my address here so I can receive some Ether. And it says give me, okay, how much Ether do you want? There's some rate limit, so you can just do like 18.75 Ether in 3 days. So you can just select that option. And basically what you do is, okay, so first actually, oh, this is not the address here, sorry. Select network URL, community Ethereum address. Okay, so the instruction here basically is that you have to go on your social media account, so either Twitter, Facebook, or Google+, and you basically have to create a new post, and in the post is where you actually paste your Ethereum address. So for example, if you go to Twitter, make a tweet, so this is my tweet, so basically you can just paste in your address here on the tweet, right? This is my address on Rinkeby. You can just have that. You don't need anything else. You can just paste in the address. You can just delete everything, just paste in the address, and then just log in and tweet that, right? And once you tweet that, you kind of grab the tweet URL. So this kind of tells you how to grab the tweet URL, and you paste the Twitter URL in there. And once you paste that in, then you select how much Ether you want, and then they will give you these. Okay, so it looks like Lorenzo, you just joined the stream. Okay. No problem. The stream is available for replay afterwards, so don't worry if you missed something so far. Yeah, so that's how you get some testnet Ether. So once you have some testnet Ether, basically the MetaMask account here will show the balance. So you can see here I have 18.743 ETH, and it shows you the equivalent USD dollar, but this is not real USD dollars. This is just testnet Ether, so it's basically worthless. It's free. So I have some Ether. So once you have some Ether, then you can actually kind of do stuff, right? You can interact with the blockchain, interact with smart contract and things of that nature. So what we're going to do now is actually let's just create a smart contract, and we'll interact with our smart contract. We'll deploy our smart contract onto the blockchain and interact with it. Okay. So basically, the way we're going to do this is we're going to use something called Remix. So you can just go to Google and Google Remix Ethereum. So just Remix Ethereum, right? Just Google that, and the first thing pops up is the one that you need. So, so actually, let me close that because I actually have some stuff saved there. I'm gonna open a new window, remix.ethereum.org. So there's nothing like no state being saved. So the first time you come here, you'll have look something like this. So basically, it's an online IDE for smart contract development, right? So it's great for getting started quickly. You don't need to install anything, right? It's good for getting up to speed quick. So basically, the main area here you have your code editor area, and the bottom here is your your console area. You can minimize that if you want. And on the right pane, there's a bunch of different tabs and options. Let me just make this a bit bigger for you guys so you guys can see it. Okay. So yeah, so there's some options here, and then on the right, there's like a file browser here. You can basically see that when the first time you load this up, there's basically 2 files here that's created by default for you. This is like kind of like a example contract that you created. You can go ahead and close that and just delete them if you want. Just right-click and delete. We don't need these. And basically, you can also open new files as well by clicking the folder icon, and that will basically allow you to open something on your file system. So what we're going to do is click the plus button and create a new contract. What we're going to do is actually create what's called a simple counter. Basically, we're going to create a counter that counts, that allows someone to increment the count and decrement the count. Super simple, okay? But it demonstrates some important concepts. Okay, so what we're going to do, I'm going to write some code now. Pragma solidity, and then basically do 0.25, I believe. Okay, so So the first statement here is basically pragma solidity 0.4.25 with the semantic versioning with the caret there. Basically this version or greater, basically, essentially. So this is basically specify which version of the Solidity compiler that I'm using. That's basically it. So all the smart contract has to start with this line. So they know which version of the compiler you're using. Okay. So to create a contract, it's very simple. You use the contract keyword and then the name of the contract. So I'm creating a simple counter. So as you can see, contract is a keyword, kind of similar to the class keyword. For those of you who have done object-oriented programming before, right? It's similar to that. So contract, you replace class with a contract. Okay. Not too bad. Okay. Now the contract, we have some internal state, right? The internal state is the state of the counter. So it says 0, 1, 2, 3. What is it, right? So we want to keep track of a counter. So we'll use an integer for that. So we'll use integer, and basically we use int256 counter. Okay. So in Solidity, if I just specify int by default, is actually 256-bit integer. Okay. So by default, integers, unsigned integers are 256-bit by default. So that's, I believe that's basically 32 byte. 256 divided by 8. Yeah, it's 32 bytes. Okay, not 32 bits, guys. 32 bytes, which is very different from a traditional machine, which is 32-bit integer, which is 4 byte, right? In Solidity, because of the way that it uses cryptographic digital signatures and things of that nature, and dealing with large values, by default is 256-bit. Okay, that's just something to keep in mind. So we basically want to declare an integer as our state variable. Okay, as you can see, this is already kind of different from JavaScript, right? JavaScript is kind of like a dynamically typed language where you don't need to specify the type of a variable. For example, to declare a variable I, it could be an integer, it could be a string, it could be reassigned to a different type later, which is great. But in Solidity, it's a statically typed language, so you have to define the type of a variable at the time when you declare it, right? So here I declare a counter, so I need to specify the type. But okay, so the other thing we need to do is there's a concept of a constructor. So the constructor is a keyword, right? And basically, I'm just going to type this real quick. Okay, so constructor, and it takes in some parameters. If it does take parameters, right? You can definitely pass in integer as a parameter here if you want to initialize the counter to some non-zero value, for example. So here we're just going to set our counter to equal to 0 to start, right? So there's also this public keyword, okay? So the public keyword is a visibility modifier. So I'm sure you guys done Java and C++ programming, you're very familiar with this concept of visibility modifier. But for those who haven't, basically public means that this function here, the constructor, can basically be called by anyone. That means the person who created the contract or anyone really who have the source code can really just call this, can deploy this contract essentially, okay? Public basically means anyone can call it. Private means that only this contract can call it. And there's also external and internal, but we won't get into that for this lesson. We'll dive into more of that in a future lesson in the next week when we dive deeper into smart contracts. So you can write functions, right? Functions. For example, we can write a function called getCounter, and increment counter, for example. Okay, increment counter, or just increment. That's, it's already obvious what it does, right? So increment counter. So what we can do is just increment the counter by 1. So plus equal 1. So again, functions. So constructor is a special function, so you have to use the constructor keyword. The function is for any other functions that's useful in your smart contract. So for example here, basically, I use the function keyword, and then the same thing, you can have the visibility modifier, you can pass in parameters. And here, I'm just changing the state, okay? Obviously, we can increment it. We can also decrement it, right? Decrement. So counter minus equal 1, right? So that's pretty straightforward. Let's write one more function to demonstrate something called getCounter, for example. This one's slightly more complicated, and it has more syntax involved. I'll explain what it means, okay? So the first two functions actually modifies our counter variable, right? Our member variable or state variable, okay? The getCounter is really just getting the value. So this view keyword, basically think of it like a constant keyword. Basically says that, oh, this function just looks at the state of the blockchain or the smart contract, but it doesn't change it. And the reason why you can do this is because it's something called gas, as you'll learn in this lesson, I believe, in this week's lesson. So basically, essentially in Ethereum, whenever you are changing the state of a contract or you're sending a transaction to the blockchain, it will cost you money to do so. There's a couple different reasons why. When you watch this week's lesson, you understand. But one is to prevent DDoS attack and basically preventing infinite loop from taking down the network, essentially. So basically, for your function that only reads data from the blockchain, it's actually free. So what this means is that you don't actually have to send money to read data from the blockchain. But whenever you want to update the state of the blockchain, right, that's going to cost money. So in our function here, the increment and the decrement function, because it changes the state of our smart contract with the internal state variable here, then it costs money. But here, if we were just reading it, if you just return counter, then it basically is free. And the public keyword is the same, so anyone can call this. And then this is how you do a return something from a function. You have to specify what it returns. In this case, I'm returning an integer. And like I mentioned, if I don't specify the size of the integer, it defaults to 256. But it's good practice to be explicit. But if you don't, it defaults to 256, okay? Now, our state variable here can also be modified. You can definitely say public here for your counter, or make it private. But by default, it's private, okay? And for functions, by default, it's public. So if I don't specify public here, this defaults to public. But it's good to be explicit in your code. But for these state variables, if you don't specify public, it defaults to private, okay? So that's just something to keep in mind. Now, to run this contract, so this contract is pretty much done. It's pretty straightforward. As you can see, it's kind of like a hello world, but slightly more sophisticated. I didn't want to do a little hello world contract. So for example, here, let's take this for a run, okay? So on the right pane here, there's a bunch of different details. So we can actually compile our contract. So we can do auto compile here, and then it'll basically, if you select the auto compile, basically every time you change the source code, you just automatically start compiling your contract code, okay? So okay, so now everything is good. You can see that it has a green mark. Everything's good. Simple counter has finished. You can definitely check out more details. You can, there's a bunch of different options here, but we'll keep it simple. We'll learn more about them later on in this course, okay? And okay, so here, if you go to the Run tab, is where you can actually take your contract for a spin, okay? So there's different ways you can run this contract. We'll learn more about the various ways later on in this course, but today I'm going to show you two ways, okay? One is called basically, so how you would do this in Remix is the first thing called environment here is if you select the dropdown, there's actually 3 different options for you here. So the first option called JavaScript VM. So what does that stand for, right? Well, we know what VM is now. It's virtual machine, right? So it's JavaScript virtual machine. So what that means is that every browser comes with a JavaScript runtime or JavaScript VM. So because your browser needs to execute JavaScript code, right? So in your browser, there's a JavaScript engine that executes JavaScript code. So what this means is that you can actually run your contract. So Remix has basically implemented kind of like a test blockchain purely in JavaScript. And if you select this first option here, if I select this, this will basically run it locally inside your browser. So it's basically, it's like an isolated blockchain. It only runs in your browser by itself. There's no mining involved. There's no other actors involved. It just mimics the behavior of what it would actually do on the blockchain. But the purpose of this is great for testing when you're in development. You get instant feedback because if you do deploy to the real network, as I will show you in a bit, you have to wait for mining to happen. You have to wait for the transaction to be received by the network and wait for the miner to include the transaction in the block and then propagate that to the rest of the network. It basically takes some time, like roughly 15, 30 seconds, sometimes up to a couple of minutes, okay? So here, I'm going to select the very first one to show you guys how this works. When you select the first one, you can see the accounts here. This is actually the automatically created 5 accounts. So these are 5 different wallets, as you can think of. You know how we earlier created a MetaMask wallet? So this has nothing to do with MetaMask now. This is all local accounts inside the VM. So there's just some test accounts, and each one have 100 Ether each. but they're not real money. They're just testnet Ether. And if you need more accounts, you can click the add button to create more accounts. So here I selected my simple counter, and I can actually deploy this contract right here by clicking the deploy. Okay, so here I click deploy. You can see deploy contract. I have a new instance here, right? You can see if I click deploy again, actually you can see there's 2 of them now. So that's the one thing I want to talk about is whenever, it's kind of like when you do object-oriented programming, how are naming complex for public functions handles? So I guess you're asking about overloading a function name. Yeah, you can overload a function name right now. I don't think in Solidity. If you had like the same name with a different return type, I don't think that is supported right now. So the function names has to be all unique and different. Okay. Okay. So I want to talk about I have 2 different contracts here, and they have 2 different addresses. As you can see, one starts with 692, the other one starts with BBF. It's kind of like in object-oriented programming when you define a class. You can create many new instances of that class, right? With a new keyword, for example, like new object, right? My new car, for example, right? Every time you create a new instance of that object actually gets created in memory, for example, and they have different address in memory, essentially, right? So same with smart contracts here. You write the smart contract once. That's kind of like your blueprint for the code. But you can create many instances of the smart contract, right? Like similar to object-oriented programming. So you can deploy multiple instances of the smart contract, and each contract will have a different address. So this address is very similar to my user wallet address. Okay. So Ethereum contracts are basically like user accounts, essentially. They can hold they can hold Ether. They can transfer Ether to another address, whether it's a contract address or a user account, and they can basically have code that they can execute. In addition to, that's kind of the difference between a smart contract and just a regular user account. The regular user account, I can only host some Ether. I can send transaction to the blockchain to execute some code. I can send Ether to other people, but I don't myself do not have any code. Okay. So as you can see here, I have 2. I'm just going to get rid of one of them and just keep it simple. As you can see, if I click the get counter value, I can see that its value is 0, right? If you click the increment, actually bring up the console here, you can see the console showing the different transaction going through, and you can click the details and to learn more about this. So don't worry too much about it. We're going to dive into deeper details about smart contract stuff next week. But this is just a teaser of what's to come next week, okay? So and now if I click counter, you can see that the value actually incremented to 1. So, and if I do similarly, if I do increment again, I get counter is 2, increment again, get counter is 3, and if I do decrement, get counter, now it goes back to 2. Okay, so let's see if there are any questions so far. Okay, no questions so far. Okay, so so that's kind of how you would basically test it really quickly with this, user interface here. They kind of created these nice buttons for you so you can interact with it. Does Solidity create the interface itself? Tony is asking. So I'm assuming you're talking about the UI interface here, right? These buttons and stuff. So this is a feature of Solidity. This is a feature of the Remix IDE. So the IDE provides all these things for you. If you're writing a smart contract, say on your computer in your code editor, like in Atom or Microsoft Visual Studio Code, or like whatever editor you use, you're writing this contract, but these buttons are not created for you. This is why you use the IDE, because the IDE provides this nice tool, right? So Remix is a great IDE to get started. It has a lot of nice features that allow you to test things really quickly. We'll be using this for some time in our course, but we'll also be using some more advanced tools that you download on your computer that allow you to basically do other things that Remix lacks. As you'll see, we get into more deeper and deeper into this course. Remix is as great as it is. It's only good up to a certain point. When your project becomes more complicated, has multiple files, and you have different deployment schemes, then it's going to be more headache than some of the other tools we'll be learning, called Truffle. Okay, so these interfaces are provided by Remix. When you compile and came to run and deploy, these are provided for you. Okay. Now, the way you create a real app, how you create a front end and interact with a smart contract, we'll learn all about that in the future weeks, okay? So don't worry about how you will create these stuff for now. This is just a tool to use, and we'll learn how to create our own interface with our own UI buttons and stuff like that in a future in the future weeks, okay? Not this week, okay? This is just a teaser right now. So yeah, okay, no more other questions. Okay, so that's how you interact with it. But now I'm going to show you how to interact with the real with the testnet Ether account, right? So if you select the injected Web3, basically what happens is injected Web3. Basically what that means is that because I have MetaMask Chrome extension installed, what MetaMask does is actually inject an instance of basically what's called a provider into this browser environment. So the Remix can actually automatically detect that I have MetaMask installed, and basically when you select it, you can see that my Ether account shows up here, E1101 whatever, and it was 18.75 Ether, right? Which matches the one in MetaMask, okay? Yes, Lorenzo, exactly. So every time you create, when you want to change the state on the blockchain, you're creating a transaction and sending that transaction to the network, and the miners are picking up that transaction and including in that block and mining a new block and broadcasting it to the entire network. So it's definitely a whole new world. It's a different model of computation. It is something definitely very new, and at first it's kind of like really weird, but as you go through this course, you'll wrap your mind around it. Okay, so basically, yeah, I have the Rincomplete testnet here. So I'm going to select this, and I'm actually going to deploy our contract now onto the testnet Ether. Okay, so I can click the deploy button again, but you can notice that this time the MetaMask notification actually popped up. So this is part of the Chrome extension, MetaMask, and this says, hey, looks like you're wanting to send a transaction to the network. And this transaction, basically, I'm actually creating a new contract, right? So the way you create contract is also sending a transaction to the Bitcoin network. I mean, not Bitcoin, sorry, Ethereum network. And basically, similar to the increment and decrement, but the parameters within the transaction are different. And the parameters now says I want to create a new contract. And the contract is basically the EVM bytecode representation of our contract here. It gets compiled down to bytecode, and this bytecode is actually sent along with the transaction to the network, okay? So now all these little details, you'll learn more about it in a future week lesson, but I'm just kind of giving you a brief overview right now. So you can just click submit, okay? You click submit, and if you actually click the MetaMask thing, it says transaction, you can see the transaction history, right? Sent. So if you actually click this, click the transaction, this will take you to basically what's called Block Explorer. The Block Explorer basically says that, okay, I'm going to show you the homepage here. Actually, this week's week 1 project is about Block Explorer. So this just shows you like the latest block on the Ethereum blockchain, how many transactions are inside, and you know, all of that different transaction history, all the different transactions. So we send our transaction. Okay, so you can see actually went through, it's successful. This is input data here, right? You can see input data is a bunch of just a string of bytes. So these are like the bytecode representation of our smart contract, okay? So, and you can see that the contract now has an address, 5A something. If you click this, it'll take you to the contract address. So when you're doing this yourself, you're gonna have a different contract address because you're sending it from a totally different account from me. So I encourage you guys to play with this. And what's cool is inside of Remix, actually, you can see that the deploy, the instance here, the address here, 5A0, actually matches the one on the actual blockchain, right? On the testnet blockchain. So this is actually live, guys. Like anyone in the world, if you give them this address, they can come to the Block Explorer and see it, and they can interact with it. So that's what's cool about it, right? So right now, for example, for those of you who are watching, if I send you this, you see how here a simple counter, instead of deploying it, you can actually load a contract from address. So you can copy this address and paste it in. You just need to put a quotation mark around the address, like the double quotes, and you can actually load this contract into Remix. So if someone else, if I send you this address right now, for example, let me send you guys in the Slack channel, for example. I'm just sending it into the question channel. If you paste this in, if for those of you who are following along, you can actually paste it in and load it up, and then you can click this increment and decrement and actually interact with my contract that I deployed. When you do that though, right, so if I call this get counter right now is 0, for example, and if I want to do the increment, the MetaMask notification will pop up again and says, hey, are you sure you want to do this transaction to basically increment this? This will cost you this amount of fee. You can see the total fee there. It cost me 1 cent USD. Okay, it's not even real money anyways. This is a testnet ether, so it's fake. I don't care. So say, yeah, I want to increment it. Doesn't matter. Submit, and then actually under your contract, right? Your contract address. If you refresh this, you can see the list of transaction history that happened in your contract. So this might take a few seconds to show up, for this to show up actually, but it will show up eventually. Like I mentioned, this is not instantaneous compared to the JavaScript VM version. When you run it there, you instantaneous get the feedback, right? This takes some time, 10, 15 seconds, sometimes up to a minute, depending on the now you see there's 2 transactions happen. The first one is the contract creation always, right? You create the contract. And now I have another transaction that basically does something. If you click it, you'll see more details, but we won't get into that detail right now. But you can see that this transaction went through and it's being mined and now everything is all good. Now if I click the get counter value, I get 1. So if you guys are following along and you guys want to interact with this, you can definitely increment and decrement it and actually go see the value and see the counter being updated, right? So that's the really cool part, is that when you write a smart contract, you deploy it onto the blockchain, then basically because Ethereum is a public blockchain, that means anyone can participate, anyone can basically interact with your contract. And typically you wouldn't expect a user to use Remix and load up the address. You build like a front end, like a website, right, where the user interacts with you, right? But since you guys are developers, you guys know how. I'm just showing you guys how to do this. You can definitely interact with this if you want, and we'll learn more about how to build a front end and all of that stuff for sure in the future lessons. So kind of to wrap up today's live class, basically this week, basically going back to what you guys are doing this week, basically week 1 is all about the important concepts and theories that underpins the blockchain technology for those of you who are joining late, right? So definitely go through all the lessons and watch the videos, take a look at the keynotes and some of the links if you're interested. And there's some quiz questions here for you guys to kind of check your knowledge to make sure you understand it correctly. And basically there's a project at the end of this week as well, and just kind of go through this project. It's very simple actually. Basically you're creating a block explorer similar to kind of Etherscan, but a lot simpler version of it. And basically we're using some libraries to help you do this. You'll be creating a simple HTML web page essentially, and then you'll create something like this showing the block number, the hash, and the timestamp, and things of that nature. So week 1 is all about important concept and theory. Those are really useful to understand, so you understand, oh, this is how blockchain work. Yeah, because it costs fee, would it be appropriate for application with a lot of high volume of transaction, right? That's a very, very good question, right? So it depends. So there's a couple of different ways of doing it. Essentially, there's one model where you allow the user of your application to pay money, right? But that can kind of depending on your application. Say, for example, like a social media, if it costs users money to create a post, for example, then no one's probably going to use your thing, right? There are ways for you to actually, as a product, to basically take the cost away from the user. So there's some advanced technique that you can do that basically allow you take the hit for the user. But there's a lot of different blockchain projects happening right now. This space is growing really fast. There's basically a lot of different interesting and cool projects out there. For example, some of the other projects like Cosmos that allow you to basically, or EOS even, right? EOS promise basically you don't have any fees. But we'll see how that project goes. It's still just getting started. So there are different, and there's also private blockchain solutions. So if you're doing like something like private, for example, if you're a big corporation enterprise, you don't want your data just to be accessible by anyone, but you also want all the different internal cogs within your organization to use a system that improves its efficiencies. So there's private blockchain solutions out there that basically allow you to do certain applications that without incurring fees. So yeah, that's a really good question, Grant. It depends on the application specific thing, and it depends on whether or not you want to take the hit with the transaction cost or you want the users to pay for it. or you want to use some proprietary private blockchain solution or some other different blockchain solutions. But regardless of what blockchain solution you use, learning about the important concepts that underpins basically all blockchains at this point, all these concepts, is really useful. And learning Ethereum will help you learn many other. We don't know. This space is so young right now. Like maybe 3-4 years from now, Ethereum may not be the king of blockchain or smart contract. Maybe some other project will come along. But even if that project comes along, you will learn the lessons from Ethereum of why, say, Ethereum failed, right? If it fails, right? Well, if you know Ethereum and you play with it, you can kind of firsthand know, like, oh, what you like about it, what you didn't like about it, and you can kind of adopt the new solution much easier as well, okay? So, yeah, so thank you guys for watching. If you guys have questions, definitely type them. I'll check the forum and on Slack as well. But if you guys have some questions right now, I'll definitely answer them right now since I'm already here. If not, great. Like I mentioned to you guys, if you guys join late, the submission for the project deadlines is basically every Monday. So for example, week 1, the project for week 1 is due on next Monday. And basically, yeah, so basically, if you need more time, just message us, let us know. Yeah, we understand you guys are busy. Jason has a question: how would you associate physical asset on the blockchain? Like, yeah, that's a really good question too. So for example, there's some IoT devices and stuff like that you can definitely connect to the internet, and they can kind of be connected to the network. But things like, say, if you want to even say create a contract that basically want to say reward user based on some external event like the weather or the stock, there's some things called oracles that basically allow you to feed real world data into the blockchain. These are more advanced concepts that we won't dive into right now, but even like a physical asset, like a piece of gold bar, right, or like a diamond. So there are projects out there are even doing supply chain stuff with diamond authenticity, right? Each piece of diamond would have kind of some unique identifier or like some small chip that it can embed into the device, for example, embed into the diamond, or some QR code, for example. And when you scan that, that's kind of like a unique identifier, and you can store that unique identifier on the blockchain in a particular application, and you can see maybe the origin and history, where this diamond came from, which country it came from, who was the producer, who was the manufacturer, all that stuff, to make sure it's authentic and things of that nature. So these are still kind of being worked out. They are definitely interesting stuff, like even real estate, for example, like deeds and titles and stuff. How would you upload that, right? But basically, deeds and titles are kind of documents. You can have electronic versions of documents, and once you have these documents, as you learn in this week's course about cryptography and hashing, you can hash some documents and store the hash. Is a very efficient representation of a document, and store that on the blockchain as well. So you can actually create a blockchain network to buy and sell things. Yeah, you can definitely do that. I mean, people are selling coins right now with these initial coin offerings, where like, hey, I have some coin that you can buy that does something. Most of them are scams. Most of them are actually going to fail. So I personally would not recommend buying into any just ICOs unless they're really legit. But even people can definitely sell whatever. Like, for example, one of the projects is called SpankChain. What they're doing is in the adult industry, entertainment industry, to have basically adult performers and viewers pay each other in crypto, and through that platform, right? So you can definitely use this to create things like, as you learn in the next week, we'll be creating a bunch of contracts. One of the contracts we're going to create is called escrow contract that will facilitate trade, for example, right? A basic proof of concept idea that could be taken further to implement like a real, like say, decentralized Amazon, for example. But whether or not that's successful, we'll see, right? But yeah, so definitely there's in terms of what you can do with the application, like because it's a general purpose programming language, you can write whatever logic you want, essentially, right? So that's the beauty of it. Mm-hmm. Yeah, so IOTA was designed for the Internet of Things and microtransactions, things of that nature. But IOTA project has a lot of interesting, let's just say interesting characteristics that makes it makes me kind of skeptical, but I'm open to it if they prove that they're successful. But yeah, there's a lot of different projects going on in this space right now. It's great. It's great to see that a lot of you are already kind of familiar with some of the project and some of the ERC-721 tokens, like Bobby mentioned, right? We'll be learning more about ERC-721 token in this course for sure. And yeah, and it's great to see you guys are engaging on the forums, guys, in the questions. Like, a lot of you guys are helping your fellow students, and that's what we want to create. We're here to answer your questions too, but we're not always available 100% immediately, right? So it's definitely great to, if you have any question, post the question into the question channel so that, other students may be struggling with the same questions. We can answer it and they can see the answer. And also, a lot of you guys are helping your other fellow classmates as well. I think someone just had a question earlier before the class started. I see some of you guys jumping in and helping answer these questions. It's great to see that. I love the engagement, guys. Definitely keep it up. And yeah, I hope you guys, yeah, I'm really excited. I really hope you guys learn something useful out of this program and take your skill level, career, whatever intention you will have after this course. Hopefully, yeah, go and do it. Thanks for watching, and the next live class will be next Monday again at 7 p.m. So that's the weekly schedule right now for 7 p.m. Seems like most of you are able to make it, so it's great. We'll keep it at that time for now. So yeah, definitely thank you guys for tuning in. I know it's dinner time. Some of you guys maybe haven't eaten yet, so yeah. Ask questions in the question channel, and if you haven't submitted the week 0 assessment, just submit them whenever you can, as soon as possible in the next day or two. But I know we're just getting started. Things are slowly picking up. We're giving you guys some leeway, but week 2, 3, and 4 is going to be a lot more coding. So it's good to catch up. I don't want you guys to fall behind, okay? If you have questions, post them in the channel. We'll try to help you guys whenever we can. And yeah, thank you guys for watching, and I'll see you guys next Monday.